Hi guys, this is Sabi from Engineering Master. Welcome to another episode of Engineering Master. Transformer is a very important subject in electrical engineering. We are doing a transformer series. This is another installment of a transformer series. In this video, we are discussing about conservator, breather and Buchholz relay. What is conservator? Conservator is a part of an oil-cooled transformer. The conservator is a cylindrical metal drum that situates nearly on top of the transformer and it is connected through a pipe. We can see this. This is the conservator. A cylindrical metal drum and connected through a pipe. The function of conservator is to take care of the expansion and contraction of oil during its operation. We know oil-filled transformer is filled with oil. This oil provides insulating properties as well as cooling. This transformer oil should not be in touch with moisture air. If moisture is in touch with transformer oil, its insulating property weakens and it may chance of some acidity formation also. So this will weaken the insulating as well as cooling property of the oil. In order to avoid that, we are using conservator. The transformer is filled with an oil in such a way that the conservator also partially filled. What happens during operation? When operation, the oil inside the transformer will expand or will be heated. So this expanded oil is going to the conservator. Conservator is partially filled with oil and partially filled with air. When heating or the expansion, the oil comes into the conservator. It will push out the air. After cooling down or reduction of the temperature, the oil comes back to the transformer. Then some air is drawn into the conservator. When oil expands, air in the conservator is pushed out. When transformer cools, some air is drawn from the atmosphere. So this process is called breathing. As we said earlier, the transformer oil should not be in contact with moistured air. The air should not contain any moisture. For this purpose, we are using a mechanism. You may have seen this with the transformer. It is attached to the conservator. This arrangement is called breather. You can see this is an enlarged picture of a breather. The function of breather is to extract the moisture from air going to the conservator. The air is going to the conservator through breather. So this breather will extract the moisture from air. You can see these blue crystals, right? This crystal is a silica gel crystal. So breather is a small container filled with silica gel which extracts the moisture from atmospheric air. The condition of silica gels, that is breather, has to be periodically inspected and it should be taken care. The another one is Buchholz relay. You may have seen this apparatus above the transformer. If you look at closely an oil-cooled transformer about 250 kVA, you can see this apparatus. This is called Buchholz relay. The function of Buchholz relay is to protection of oil-filled transformers from incipient faults. The Buchholz relay protect the transformer from faults. How is it working? Let's look into it. Buchholz relay has two floats. For easiness of imagination, you can imagine this as a float in a flush tank. So it will be similar like this, right? Imagine these floats like a float in our flush tank. What is happening when fault occurs? The transformer oil is suddenly heated. Because of that, some air bubbles will form. This oil is flowing in this direction, right? So this air bubble is trapped on the top of the Buchholz relay. Some space will be occupied by the air bubbles. So automatically the oil level will reduce. So this float is floated above the oil, right? When the oil level reduces, this float also will come down like this. There is a mercury switch attached with it, okay? When this come down, these two contacts will be in connection. This will trigger an alarm. When float A activated, there will be alarm signal. So there will be an alarm. So this maintenance person or facility management persons can go there and inspect the transformer. This is a function of a float A. So if you look at this closely, you can see a valve-like arrangement on top, right? So when we open this, the gas will be released. A trained person can understand the fault nature by inspecting the gases. There is one more float, right? Float B. What is the function? This float B will not be activated in normal conditions, okay? If it's a minor fault also, it will not be activated. You know, when the transformer is in normal condition, the oil is passing to the conservator through the Buchholz relay and it is heating the float B. There will not be any effect in the normal condition. When suddenly some large fault occurs, what happens? The air bubble formation will be violent or in high amount. This causes a sudden displacement of oil, okay? During the large fault, the oil will be displaced suddenly or the velocity of oil displacement is increased. So in this scenario, this oil will hit the float in violent way. What happens? The float will be displaced. So again, there is a mercury switch attached with it. This displacement of float will trigger the mercury switch and it is connected to a trip circuit. So the transformer will trip suddenly. During the heavy fault, the transformer will trip suddenly. There are two functions of this Buchholz relay. One is alarm, other one is trip. Alarm is in a normal or minor fault condition, trip in a heavy fault condition. So that's it, guys. I think you got a fair idea about conservator, breather and Buchholz relay. We will continue the transformer series in coming videos. If you like the video, please like, share and subscribe. Thank you.